So today we're going to be talking about TIG welding versus electron beam welding. So I just wanted to start off by thanking everyone for joining today to learn about the differences between TIG and electron beam welding. My name is Corey Eager. I'm the Director of Operations at EB Industries. Also with me is Dominic Rocco. He is the Sales Engineer at EB Industries. So a couple of things before we get started. We'll be sending out the slide deck and a recording of this presentation in the next day or two. So don't feel like you have to scramble to be taking notes. Any questions that you have throughout the presentation, please put them in the chat and we will answer them at the end. And all attendees are going to be muted to avoid any background noise and any disruptions. So just jumping into it, welding is a critical technology that the aerospace, medical, defense, and many other industries rely on to manufacture the components they need. Choosing a welding technique can make or break your project, so it's important to understand what options are available and when to choose one over the other. This presentation compares TIG and EB welding, two of the most common ways to weld metals, to help understand the distinctions between them. When choosing any weld technique, it's important to understand which is best for your application, since each has advantages in precision, penetration, energy usage, ability to weld challenging materials, part size, and even safety. This webinar is going to discuss those differences in greater detail, and we'll cover the items listed on the slide above. First, let's talk about TIG welding. Tungsten inert gas, or TIG welding. TIG welding transmits electricity through a non-consumable tungsten electrode to form an arc with the metal at the weld site. Most TIG welds require the use of a filler metal. An inert gas is used to keep the weld free from contamination. Without proper shielding, gases in the air, like oxygen, and in the case of titanium, nitrogen, will react with the metal to form oxides and other compounds that can introduce impurities into the weld and weaken it. Using an inert gas and shield instead of a slag to protect the weld pool, this process was a highly attractive replacement for gas and manual metal arc welding. TIG welding became an overnight success in the 1940s for joining magnesium and aluminum. TIG welding has played a major role in the acceptance of aluminum for high-quality welding and structural applications. Just quickly want to touch on another conventional welding process called MIG welding, gas metal arc welding. It's a welding process in which an electric arc forms between a consumable MIG wire electrode and the workpiece metal, which heats the metal, causing it to fuse. Along with the wire electrode, a shielding gas feeds through the welding gun, which shields the process from atmospheric contamination. This process can be semi-automatic or automatic. A constant voltage is required. DC power source is most commonly used, but constant current systems as well as AC current can be used as well. There are four primary methods of metal transfer: globular, short-circuiting, spray, and pulse spray, each of which has distinct properties and corresponding advantages. A couple examples of where TIG welding is used is food and medical equipment, where complete fusion and good surface finish is required to prevent contamination, tubing for high vacuum systems, high purity gas systems, jet and rocket engines, and in automotive, industrial, and aircraft exhaust systems. Now we're going to talk about electron beam welding. Electron beam welding machines are capable of delivering incredible amounts of power, up to 10,000 kilowatts per millimeter cubed. These machines typically come in two voltage classifications, where low voltage is 60 kilovolts and high voltage is 150 kV. EB welding is capable of producing a weld 3 inches deep in steel with a width of approximately 10% of the penetration depth. This creates a cross-sectional view that has a similar appearance to a railroad spike. The acceleration of electrons can only be done under high vacuum, which is why the process is done inside of a vacuum chamber. Otherwise, the air and gas particles will scatter and diffuse the electrons, which will lead to an inefficient joining process as the energy won't be uniformly applied to the workpiece. Due to needing to be done in a vacuum, as well as the radiation that this process does generate, human handling isn't possible with a part inside of the vacuum chamber. This process requires highly trained weld development engineers and highly skilled operators to ensure repeatable and consistent results. These machines typically cost millions of dollars to purchase and maintain due to the intricacies of the many systems involved in the machine, including the vacuum pumps, the high voltage tanks, the inner wiring of the machines, and many other characteristics. Now, just to talk about the science of electron beam welding. So free electrons flow through a tungsten filament under vacuum by accelerating the electrons with a high voltage power source. Their path is controlled through magnetic lenses that can deflect the beam or control its shape by controlling its diameter by producing a narrow adjustable cone. By colliding the electrons with metal, the kinetic energy is transferred into heat on the workpiece, thereby producing a weld. Success and quality of the final weldment depends on proper joint design and proper tooling. Electron beams must be generated, focused, and aligned at setup according to a predetermined weld schedule and synchronized with weld feed rate to produce the width, depth, also known as penetration, heat, and cosmetic finish required. Electron beam welding is the process of choice to choose when joining dissimilar metals that would otherwise be unweldable. The precise nature of the electron beam and tight heat-affected area allows EB welding to melt a lower temperature material onto the unmelted higher temperature material, resulting in a homogeneous weld. An electron beam can be very accurately placed, and the weld can retain up to 97% of the original strength of the materials. Electron beam welds are incredibly strong and pure. This is because impurities are vaporized, and being welded inside of a vacuum means there are no gases or air to react and cause oxides. Now we're going to compare the two processes. So analyzing differences of the two techniques comes down to a variety of factors: precision and control or weld quality, their ability for micro welding, penetration/heat input, vacuum environment, versatility with materials, material distortion during the weld, throughput, and safety. So there are several notable advantages to TIG welding for some applications. If TIG welding is an appropriate option for a project, it is often less expensive than something like electron beam welding. It can be more flexible for working with large pieces, since some welding applications have size restrictions, like for electron beam welding, it is a vacuum chamber size, and in laser welding, it's table travel. In addition, TIG welds are excellent for rough cut parts that have gaps between the surfaces to be welded, since the required filler metal can fill those spaces in. However, while many are attracted to TIG welding as a low-cost approach, there are a variety of performance disadvantages to TIG welding that the engineering and quality teams must take into consideration. While TIG welds have some areas where they shine, there are several factors that limit their use. The welding process is slower than many other kinds of welds because it's about 5 inches per minute, which in turn makes the weld less precise and lengthens production time. It can also be more difficult to use TIG welding to join dissimilar metals if they have properties that make them less compatible, such as different melting points. Now we're going to talk about the advantages of EB welding. So the first thing we're going to talk about is the higher quality welds. Welds made with electron beams can have a very high aspect ratio, or in other words, they have a deep, narrow structure compared to other types of welding. The ratio of width to depth can be as low as 1 to 10 compared to 1 to 4 for laser welding. This is because electron beams can be focused more intensely in a small area, so they're capable of heating sections of metal a lot faster than TIG welding can. Since the beam can be applied for a shorter amount of time, there's less time for heat to spread through the material. This means that the weld will have less distortion and a smaller heat-affected zone. The heat-affected zone is the area on the metal that isn't part of the weld, but where the heat dissipating from the weld is enough to change some of the material properties of the metal. Minimizing the heat-affected zone creates stronger welds since the material is more consistent throughout the piece. The vacuum environment required by the electron beam also ensures the weld will have little to no impurities that can affect the material properties of the metals or otherwise weaken the weld. Another thing is the high repeatability, precision, and control. Electron beam welding works extremely well with manufacturing a lot of the same pieces over and over again. This is because the beam's precision and accuracy keeps welds consistent across multiple pieces, where a weld done by hand may have variations in the applied heat. That means that EB welds will have more consistent material properties for multiple components. In general, EB welding provides unparalleled precision and control over the weld, reducing thermal distortion and allowing for the joining of complex and delicate components with remarkable accuracy. Being that the process takes place in a vacuum, the process must be at least semi-automatic. The parameters and feed rate remain constant for the length of the job, with a much reduced possibility of human error. In addition, many facilities that provide EB welding services, such as EB Industries, are already equipped with CNC machines and make it straightforward to program repeated actions. Programming the actions needed to perform the welds makes automation not just possible, but also fast and reliable. Setting up a machine may take some initial investment in time and testing, but with high volumes of welds, it can save a lot of resources. Another area where EB welding thrives is in micro welding. The accuracy and precision that electron beams are capable of makes them excellent at making welds that are very small, including welding things like tiny syringe needles or tubing that is less than 0.5 millimeter thick. Also, the lack of contamination due to the vacuum environment is critical, since even small impurities can have an impact at such a small scale. EB welding is also great at deep penetration. EB welding can achieve deep penetration in a single pass without the need for filler metal, as mentioned earlier, thanks to its high energy density. This is particularly beneficial for thick sections that would require multiple passes using TIG welding, which saves time and reduces material stress due to a lower heat input. There's also no need for filler material because there's a high enough energy density that causes the parent metals to melt and fuse together. Another reason is the vacuum environment. While the requirement for a vacuum may seem like a limitation or complexity for your plant, it actually offers several benefits. Welding in a vacuum eliminates the possibility of oxidation and contamination, which leads to cleaner and stronger welds. This is especially important for materials that are sensitive to atmospheric gases. An area where EB welding really thrives is in welding dissimilar and complicated metal combinations. This makes it ideal for applications where advanced materials and material combinations are common, such as in aerospace, nuclear, and defense. Welding metals with different properties can get complicated quickly due to differences in melting points, coefficients of thermal expansion, heat transfer rates, and other variables. Most types of welding requires both of the dissimilar metals to melt in order to form the weld, but electron beam welding can be used to melt one metal directly onto the other if there's enough of a difference in melting points. EB welding can also be used to weld copper to other metals, such as stainless steel, which is difficult to weld due to its high thermal conductivity. The fast weld speed and high aspect ratio makes welding copper much more manageable than it would be with some other methods of welding. And you can see on this slide above, we have a cross-sectional view of a stainless steel through copper weld example to show you how successful that can be using EB welding. Two other things that EB welding is great with is increasing throughput and safety. The ability to automate EB welds reduces the amount of time needed to process a large quantity of the same piece. But it isn't the only reason why EB welding is a good choice for this type of work. The time it takes to do the weld itself is a lot faster than most other kinds of welding at feeder rates up to 200 inches per minute. And just for reference, this is about 40 times faster than an average TIG weld. For high volume production environments, especially those involving small to medium sized components that can be easily loaded into a vacuum chamber, EB welding can offer higher throughput rates in ways that can reduce labor costs and enhance consistency across welds. And of course, never an afterthought, electron beam welding, as an automated process that takes place inside of a vacuum chamber, greatly minimizes operator exposure to things like welding fumes and intense light, providing a safer work environment. Of course, with everything, there are limitations. Electron beam welding can do a lot, but it can't do everything. The biggest drawback to EB welding is the amount of specialized equipment, facilities, and personnel required. Vacuum chambers are expensive, complicated pieces of equipment that require maintenance and trained personnel to operate them. The electron beams need high voltage electronics, which have their own expenses and requirements. The beams also generate radioactivity while they are running, so the vacuum chambers have to be lead lined and other safety measures put into place to protect personnel during operations. So, final consideration, what do you choose? So there are some occasions when TIG welding is likely a better choice. A couple of reasons would be if the joints to be welded don't fit together well, if the weld needs to be grounded flat, or when the pieces to be welded can't fit inside of a vacuum chamber. In other cases, EB welding is usually the best option. When precision and quality are a top priority, when working with difficult materials and biometallics, and when automation would be beneficial, among other reasons. Electron beam welding's unique capabilities make it a crucial technology for critical applications. While it carries initial setup and operation costs compared to TIG welding, its advantages often justify the investment, offering unparalleled weld quality and performance that TIG welding just can't match. If electron beam welding is something that you're considering for your project, the limitations mentioned above mean you'll probably need to work with experts like our engineering team at EB Industries to have the right tools and experience to perform high-quality welds safely and reliably. Now that you've heard the differences between TIG welding and EB welding, I'm going to talk a little bit about our company and our capabilities. So EB Industries is a full-service provider of electron beam welding, and laser hermetic sealing services, as well as a contract manufacturing company with a large network for value-added processes. EB Industries has continually met the unique requirements of component fabrication companies by helping customers design, develop, and produce welded components. EB Industries also provides and manages additional services to produce complete assemblies. We do a lot of supply chain management here. Our facility is located in Long Island, New York. It's a 17,000 square foot facility. We currently cover all of the United States, Mexico, Canada, Israel, and several parts of Europe. What do? So we help customers design the right weld joint for their application using our experienced engineering team. We also have CAD, CAM, and solid modeling capabilities. So that's what we do in the design side of things. For the development side of things, we help customers develop a process, as we have a large selection of various electron beam and laser welding machines under one roof. We also have an in-house machine shop for fixturing, as well as helping with customer part modifications. Our on-site metallurgical lab allows us to cross-section, polish, and etch our weld cross-sections to ensure the internal quality of the weld is sufficient before proceeding to weld a batch of production parts. Our large network of suppliers and service providers allows us to help put together the right supply chain for you that we are very experienced with handling. So the supply chain includes processes like machining, heat treating, and several NDT processes. Finally, we help customers support their large, small, and medium production projects with our operations that are specifically designed to become an integral part of your supply chain. Our large breadth of certifications and qualifications allows us to work on and support a large variety of projects. We typically average between 1 and 2 weeks in turnaround on production projects, but because of where we are in the supply chain, we also have same and next day commencement expedited options available. So for our welding capabilities today, we have 4 high voltage EB welders. We have a 5th one that is coming online. We have 1 low voltage EB welder. Our max chamber size is 36 by 36 by 72 inches. We have several machines with 5-axis CNC control, and we also have optional real-time parameter monitor. On the laser welding side, we have 10 laser welding systems that range from 50 to 4,000 watts. We have both pulsed and continuous wave lasers. We have fixed optics and fiber optics lasers, and all of our lasers are controlled on a multi-axis CNC control workstation. For hermetic sealing, we have 2 laser welding glove boxes, automatic vacuum bake ovens, and computer-controlled environments with parameter monitoring and data logging. So for our supporting services, we offer many things in engineering. We help with weld engineering and joint design. That's a complementary service that we do with our new prospects and customers. We do tooling design and fabrication. We help with system design development in some cases as well. We do material and component sourcing, and we also perform our own metallurgical evaluation. In terms of pre and post welding services, we offer cleaning and assembly, pressure testing, heat treating, NDT like X-ray, dye pen, mag particle, and others, contract manufacturing, and some other services like coating, anodizing, passivation, post-weld machining, stress relief, among many others. For our quality, which is of course very important in our industries, we have a very unique quality management system that is designed to provide high quality work product that meets varied requirements by industries. EB Industries is on the approved supplier list for many large OEMs and tier 1 suppliers. We are certified to ISO 13485, AS 9100, ISO 9001. We are NADCAP accredited for electron beam welding, and we are able to electron beam weld to several certifications like AWS D17.1, AMS 2680, and AMS 2681. We also support several other certifications and customer certifications. So if any of those are on your list of requirements, just let us know. We can take care of that as well. Our equipment is all compliant with MIL standard 1595, and our welding operators are all certified to AWS D17.1, which is a NADCAP accredited process. Now, talking about the several industries that we support, aerospace, space, and defense. This is where our company first started. We support many projects in these industries, such as commercial and military aircraft, aircraft engines, rockets, satellites, submersible componentry, sensors and controls, ordnance, and weapon systems. Medical devices is probably our second most popular industry that we support, and the applications for those, we support medical instruments, surgical tools, implantable devices, artificial joints, and we also support many dental appliances. We also manage the supply chain processes needed to make a complete assembly in these industries. Now, a couple of industries that we also support, there are things like alternative energy, batteries, automotive, oil and gas, research and universities, semiconductor, and several other industries that we support. Now, you might be asking yourself, what is the EV industry's difference? Now, we say that our difference is that we offer extremely quick turnarounds. We offer, as I mentioned earlier, same and next day commencement expedited services. Being that we are typically at the end of the supply chain after components have been made, they're manufactured, they're integrated and assembled into larger assemblies, we know that we are at the end of the supply chain, and we always help our customers make up for lost time that occur in other places in the supply chain. Another thing that we offer and that makes a difference with us is that we offer free engineering consultation. So our engineering consultation, which is what Dominic is typically helping with as well, we help our customers design the right weld joint, as well as in some cases, actually assisting in the design of the overall assembly itself. Now, the third thing that makes a difference with us is that we have a lot of quality certifications. We are, as I mentioned before, AS 9100, ISO 9001, and ISO 13485 certified. as well as being NADCAP approved for electron beam welding. On top of that, we are on the approved supplier list of many OEMs, which makes it very easy to partner with us on complicated projects. And if we are not currently on an approved supplier list, we will do whatever is necessary to become approved to be added to that list accordingly. Now, some things that are future service offerings that we're doing, one of them is TIG welding. So today, like I mentioned earlier, we offer electron beam welding, laser welding, and laser hermetic sealing, which is laser welding inside of an inert environment glove box. We are also going to bring TIG welding in-house so that we can support a larger scale of manufacturing projects, and it'll give us an ability to leverage our welding expertise in this field as well. Another thing that we're exploring bringing in-house is handheld laser welding. So basically, this process is laser welding using a handheld laser supply source, which basically mimics TIG welding, the manual aspects of it, with the benefits of laser welding. So there are a bunch of difficult laser welds that we perform here that are due to things like size, access, and location that would lead it to be more successful using a more manual process like handheld laser welding. We have also invested in a laser ablation system, which removes rust off of parts, as well as being used for internal maintenance. We use this to clean our chambers and things like that inside of the machines to make them pump down faster and better. Now, just a list of some of our customers. I'm not going to rattle through all of these, but we support a large variety of customers in the industries I mentioned before. So as you go through this list, you'll notice that there's aerospace, defense, medical, semiconductor, and then hospitals, research, everything like that. So we support an extremely wide variety of parts. We're a great company to partner with for these projects with our long, almost 60 years of experience with supporting these types of programs. So, if any tough applications, just please feel free to reach out to us and our engineering team. We'd be happy to work with you. Now we're going to open it up to questions, and we will try to answer as many as we can in the remaining time that we have. So just, as I mentioned earlier, just keep them coming in the chat, and we will answer them as we can.
Yeah, thank you, Corey. That was a good presentation, Corey. Thank you.
Mm-hmm.
I just wanted to kind of throw in a key project that we've been working on as we sort of see our business shift quite a bit towards medical instruments, and mainly implantable medical devices have become, I think one of the more larger applications that we've been seeing lately, and just something that's been thrusted into the forefront of the industry. One device in particular I can point out that we have, it took us a while to develop, and it's sort of become our bread and butter at EB Industries, is a titanium artificial heart pump assembly. We currently run, I would say, on the order of maybe a little less than 1,000 artificial heart pumps per month. It keeps one of our hermetic glove boxes quite busy, and we have I think 2 or 3 dedicated staff members that are extremely well trained on this application. But I think that's one of the more impressive projects that we run, and one of the more difficult to set up.
Yeah, thanks for bringing it up. I actually just pulled up a picture of the project that you're referring to, just to kind of get a feel of the typical work that we're talking about here. Just kind of, I guess, with some of the remaining time, and until we see some questions rolling in, one thing I just wanted to quickly just kind of go over and reiterate again, just because it's really important for us, is one of the most important things that EB welding offers as an advantage over TIG welding is the ability to weld dissimilar metal combinations. So in our industries, we are constantly being asked to melt 2 different materials together. That in classic conventional welding methods would never work, or if they were to work, it would require the use of a filler metal. Now, with our services, we don't have to use a filler metal because our electron beam welding process is extremely pure and is able to melt the better material for us onto the other material. So I just wanted to reiterate that again, that welding dissimilar metals is very common for us. It's seemingly becoming more common as time goes on, and we are extremely well equipped to do this. And another thing I just wanted to talk about again is the repeatability. So TIG welding, if it's not automated, is a bit of an art form. It requires very skilled manual technicians who would sometimes almost call themselves artists. With electron beam welding, our technicians are very highly skilled and trained, but the bulk of the involvement there that they're doing is making sure that the parts are lined up correctly, and then mostly the machine is able to do the rest. This makes it very comfortable when we're welding medium to high volumes of parts, where you can be very certain that part 1 through part 1000, if you were to section them, would have the same quality and the same results. So I just wanted to touch on those two items. Also talk about the deep penetration that we're able to achieve. Because of the minimal heat input, typically to get this deep penetration, you're hammering these parts with a very large amount of heat. But our EB welding process is very pure and it's very efficient. So we were able to achieve an extremely deep penetration. I mentioned earlier, it's upwards of 3 inches in steel with one singular pass. And that will greatly eliminate things like distortion and stress on the part and things like that, which is very important when we're talking about the longevity of some of the applications that we're working on.
Corey, I see a question popped up there from Buck. What do I consider when contemplating shifting from EB welding service to creating that ability here in-house? So the first thing that pops into my head is it's very difficult to shift EB welding services to your own in-house ability. Corey touched on it on one of his earlier slides. The equipment is incredibly costly. I think we're talking about north of $1 million to kind of just purchase the equipment alone. And that includes no equipment, no maintenance, no trained, highly skilled personnel. So I think total investment kind of once everything is procured, I think we're talking about north of 1.5 mil. So I think we always urge, if someone's contemplating bringing EB welding in-house, we always urge them that, we are the experts in this field. We hope you love and trust us. And I think you'll find that, us providing services truly worthwhile.
Yeah, just to kind of add to that, the one other thing I want to mention is the maintenance that's required of these machines. We have maintenance schedules that dictate what needs to be done monthly, quarterly, yearly, and we have trained automation engineers and system engineers that have been training for years, if not decades, on the intricacies of these machines. You could have an issue in the machine where one thing goes down and it takes 12 different ways to solve it to really figure out the actual issue. So, on top of the barrier of entry due to the costs, it's also really important to mention the skill level required to perform your own internal maintenance. And if you can't perform your own internal maintenance, when you go down and you have orders to fulfill, you're many times kind of left stranded and waiting, and due dates come up and they creep up on you. So, cost definitely is number one, and, skill level, engineering expertise, and maintenance requirements would be a couple of other reasons as well.
Maintenance is truly an unforeseen thing and can be almost just as costly in a time and replacement equipment wise the machine itself. So yeah.
Yep.
Good points.
I could touch on the second question here. Michael had asked, in the pre and post welding services, can you tell me which ones are done in-house versus with a partner? Let me just back to that slide. So I believe you're referring to this slide. So the bottom of that slide, it's saying, so just say what we do in-house. We do cleaning and assembly. We do pressure testing. We do our own, it's kind of going above, but our own metallurgical evaluation. So we do all our own cross-sectioning, polishing, etching, and measurement of weld penetration samples in-house. Obviously, the contract manufacturing is an outsourced process. We can perform stress relief. We can do post-weld machining, but most of the NDT processes like X-ray, dye pen, mag particle, we partner with third-party companies that are, NADCAM approved, ISO 9001 approved and certified to handle those processes for us. And, they become an extension of us. We like to run things with rapid turnarounds. Our service providing partners they provide us with the same level of skill and turnaround time that we need for our customers.
I see a question popping up. Laser beam quality and spot size have come a long way and provide similar results to EB in some cases. I agree with that.
Mm-hmm.
What advantage does EB still offer relative to laser? This question pops up quite a bit, especially during my sort of pre-engineering consulting calls and which process is better suited for their particular applications. My answer is always the same. EB will always offer a few certain advantages that laser just cannot duplicate. EB is much more favorable when welding crack-sensitive material. Um, uh, in particular, I think we're talking about dissimilar metal welding, certain chrome moly steels, things that we just would not really have a chance at if we were performing traditional pulse laser welding. A second thing is if you need to trap a vacuum with your weld, a lot of times we'll see aerospace valves where they'll have sort of a cap component that is covering up a cavity. And part of the requirement of that cavity is to have a certain vacuum level. Being that most of our lasers are open air, you're just not going to get that vacuum within the cavity.
And
A third reason is specification driven. When we get sent over an RFQ, sometimes it's open-ended and we have a chance to tell you why that application is better suited for one or the other. Mm-hmm. But sometimes per the specifications, mostly the AMS specifications and AWSD 17.1 specification would sort of drive it towards needing or requiring EB welding.
Yeah, Dom, one thing I was going to add as well is that electron beam welding is an incredibly higher rate of efficiency with the energy you put into the part that is able to be absorbed on the part. Lasers are typically have a challenge with welding reflective materials, things like aluminum, copper, titanium. So with an EB welding process, majority of the heat that you're putting into the part is actually being retained by the part, partly also because of the vacuum chamber we're welding in. So, the high efficiency of EB welding, it allows you to use less of a heat input to get the same result. And in some cases, you can't achieve the same depth of penetration with laser that you can in EB welding. So, like thicker parts with deeper penetration requirements that require more strength, those processes we would always defer to electron beam welding for those.
Yeah, the depth is important to touch on. And as far as laser welding has come, it is most likely never going to compete with having a 150 kilovolt high voltage tank next to the chamber. So yeah, while as we can weld almost 3 inches into steel with our EB welding equipment, it's more like a 1/4 inch max pen with our lasers.
See a question here about are our machines on welding on a single XY plane or are multiple axes supported? I would say both. We have machines that are capable of both. We have several machines that have CNC capabilities that have similar axes supporting like Michael and S, like 5-axis CNC machining. So we started off with mainly having single plane machines. And in recent years, we've been investing in developing our EB welding machines with CNC capabilities of supporting more than just 2 axes.
See another question here. What is the minimum number of parts where E-beam welding becomes competitive with TIG, thinking of prototype quantities? This is a really good question because this does pop up when new projects kind of arrive and we talk about what kind of initial investment is worthwhile. So I think the best way I can answer this is TIG does have its advantage in a way where, it's a manual welding process, whereas they can sort of access and maneuver assemblies a little bit quicker and easier than we can because EB welding takes place in the vacuum chamber. We have to make sure the part is fixtured and secured properly so that while our CNC program is moving, the part is not. So I think in a prototype quantity where the part is difficult to fixture, it may lean towards the argument of being worthwhile to TIG weld it. If you're looking and preparing to come up with a production process where TIG welding a prototype may work in the quick and dirty sense, I still think it may be worthwhile if you could support the initial investment to gear it towards EB welding, because as Corey mentioned, it's just so highly repeatable and highly efficient. There really is no comparison. It could be a greater cost comparison up front, but in the long haul, EB welding is truly a superior process.
Anyone else have anything to ask? Oh, see a question popping as soon as I said that. Oh, never mind. It was a thank you. Well, thank you guys. Of course, if you have any questions when we end this, please reach out through our website. You can give us a phone call. Our phone number is 631-293-8565. Feel free to ask for either Dominic or myself, Corey. We are happy to help you with however we can, any sort of consulting that we can offer you, any sort of weld joint design. One thing we like to tell people, and I'll leave you guys this before we sign off here, is put in the time up front to make sure that these parts are designed the right way for welding out of the gate. The worst thing that could happen, and it's something that we come across all the time, is that people on paper and on a computer screen design the perfect part. And they spend months and months and months going through review processes, redlining drawings, revising documentation. They come to us 6 months later, they say, what do you think? And we say, well, we would never have offered to design it like this. If you do this, this, and this is how we can do a repeatable printing-like process for you guys. And now you've wasted time, money. I'm sure that some of you, it's resonating back from experiences you've had in your own companies. So please don't feel like you're bothering us. We like to be helpful earlier in the process. Even if you're conceptualizing something, just tell us then and there. We're happy to help you. And again, if you have any questions come up after the fact, just feel free to contact us after we get out of the meeting, and Dominic or myself will be happy to help you.
Yeah, and the one major thing you're going to get from us is full transparency. We are going to work with you from the start. If we think it's something that could be designed and engineered towards our processes, we're going to help you. If we think it's something that we just cannot help with, or it's better suited for something else, we'll use all of our manufacturing experience to try to get your project to gain some momentum.
Yeah. Well, looks like that's all the questions we have for today. So again, contact us after if you have any more questions, but if not, thank you so much for your time, and just keep an eye out because there'll be more of these to come. So thanks for all your support and all of you guys sitting in on this with us. We really appreciate it.
Thank you.